So today we will ask Jonathan Müller, the member of C++ Standards Committee and also engineer at ThinkCell in Berlin, that how is this 40 years old language still powers the modern world?
Yeah, I wouldn't say it is despite being 40 years old. It is because it is 40 years old. C++ is a very mature language. There's so much C++ code out there, and a lot of it is in form of really great reusable libraries. So whatever you want to do, there's a library that will help you out with it. There's tooling that will help you out with it, and you can just use it to tackle the problems. C++ is good at two things. It's good if you absolutely cannot afford any overhead. So if you're like working in embedded space, or if you want to want to really control what the hardware is doing. So if you're working in the high performance space. So lots of embedded stuff, firmware, embedded devices everywhere in your car, in your microcontroller, in airplanes, they all use C++. And then high performance stuff, like the classical high performance clusters use C++ to do the computation, also to do like weather or climate simulation, stuff like that, but also like real-time systems like games, other kinds of simulations. That's where C++ really shines. All the big companies use C++ at some point, like Google, Facebook, Netflix, Amazon, Microsoft, they all use C++, and then a bunch of like tiny companies too. Compared to Python, like C++ solves entirely different. It's kind of like you wouldn't use C++ and Python for the same thing. Compared to Rust, well, Rust is new, right? C++ 40 years old. C++ has a lot of momentum, and Rust is a new language. Like who knows how it's going to be in another 40 years, right? But also like COBOL hasn't disappeared, right? There's still COBOL code out there, and I think it's the point where like as the industry, program languages can no longer die out because there's so much code there. Yeah, so C++ has the strength that over the 40 years, it hasn't really broken a lot of backwards compatibility. So you can take 40-year-old C++ code, and it will probably still run with like minor edits. So you can incrementally modernize the existing code base and still adopt the new features. And that's really makes it another thing why C++ can't be replaced, because it's just so easy to migrate to the next version of C++ compared to the whole other programming language. It's not perfect for any problem, but like it's good enough, and you can do anything with it. Like C++ sort of like takes all good programming language features and finds a way to add them to it. So you can write C++ in any shape or form that you want to do, and that makes it very flexible. So the C++ standardization committee is really huge. I think the biggest meeting was just before the pandemic, and I think it was over 200 attendees that were in person to work on C++. There are a lot of really passionate people that want to improve the language, so they write a proposal to add something, to make something nicer, to add a new feature, and then they submit it, and then they get feedback. So the C++ standardization committee is part of ISO. So it is a formal standardization body that makes them, but they don't pay people to standardize C++. The people that are there are sent there by their employees. Some of them are students, some of them are professors, but most of them are paid by their employees to go and work on C++ and make it better. The biggest difference with that is like, principally, also everybody can work on the standardization committee. It's not an invitation-only body, right? You can decide to go and show up at the C++ standardization body. So the biggest difference is that a lot of the work happens in person. It meets 3 times a week in some destination, 3 times a year for a week at some destination, and then everybody shows up and spends the entire week working on C++. Like you just need to be motivated, you just need to be passionate, and you need to be lucky enough that you can go there and then you can join. So if someone suggests a feature, they need to like write it down in form of a proposal. So it needs to come with motivation on why they would want it and a sketch on how the design should look like. This is then sent to the C++ standardization committee. If there are sort of generic new features, they end up at an incubator study group. So there's one to incubate language features and one to incubate library features. So if you were to submit a new feature for State Rangers, it will end up in my subcommittee. And then in the subcommittee, you will get feedback about how the design, do we like the design? And if the subcommittee sort of agrees, yeah, this is a good feature, we like the rough shape of it, then it gets sent to the corresponding evolution group. And they sort of nail down all the details. Like, what are the edge cases here? What happens if we combine it with this other feature? And if those groups are then also happy, then it gets forwarded to the final group, the wording design, the wording review groups. But if you made it through that process, then it gets formally sent to plenary, where there is a vote, we have this specification, do we want to adopt it for the next C++ standard? And usually that's like unanimous consent, because by this point everybody agrees because it has seen this paper, and then it gets adopted. So there is a committee meeting 3 times a year. Like in principle, like tiny bug fixes can get forwarded within like 2 meetings. But like big features can take decades. Previous iterations of contracts didn't make it, simply because people couldn't agree on what exactly they wanted it. Most features aren't, people tried something and then it gets voted down. And then that's the end of it. It's usually like people, yeah, we like this in principle, but we don't want this particular shape. For example, people repeatedly try to add a form of like uniform call syntax, where you call member functions with non-member syntax and vice versa, and just like name lookup was always complicated and it never reached the consensus. Don't have a standardization committee. Like have like a small group of people that are actually in charge of the language, right? Because C++, we have a direction group, which like for every standard process, so like every 3 years, they put up a new paper and say, hey, this is what we really want to see work on. So there isn't really someone in charge of the language, right? It's just like whatever pleases the crowd, so to speak, because it is a crowd really, like especially the language group. That's like really big. Like there are like 50 people that have to vote on everything. And yeah, it's just. So we sell a plugin for PowerPoint. So PowerPoint is sort of good enough if you're just casually doing slides. But our customers are like consultants. They have to create so many slides. And then it just takes away so much time if you manually have to like adjust every little layout box and resize it. And then you want like, oh, I want to do this data visualization, but I don't have this diagram type in PowerPoint. And we take care of it. So we like seamlessly integrate into PowerPoint. We provide automatic layouts, so you don't have to worry about that. We provide more diagram types, so you can have like a Gantt chart just very easily in PowerPoint. And it just saves our customers so much time. We are heavily invested in C++. Like we use C++ for everything, including like the backend of our website is written in C++, and we have like code that generates dynamic HTML in it. Like we are heavily invested in C++, and we sort of fully embrace the language. And it's a really interesting place to work, precisely because like if you love C++, you love working in things like because it uses the language to its fullest. If you don't like C++, then things isn't the place for you. We are a relatively small team of engineers. I think we are around 30 engineers. We have a very, like we don't have a regular meetings or stuff like that. Like we work independently, we're giving a task and then we work on the task and like talk to people as we need to talk to them. We also usually aren't giving a deadline. So unless it's like a critical bug fix, if it's just a new feature, we can just take all the time to truly deliver the feature. And so it's a really nice engineering culture because you just do software engineering. So I work remotely, fully remotely. So we have an office in Berlin, but we also hire remotely. So I work remotely. Some of my colleagues are in London and other parts of the UK. So we'd like to establish ourselves as the C++ place to work at in Europe. Right, so we want to be the top C++ company for like the best C++ engineers in Europe and try to attract them. That's why we like sponsor a bunch of conferences. Like I'm participating in like meetups like this one. I would leave out C. Right. This is sort of like the reason C++ is so popular, because you can just take C code, at least at the time, and just start using it as C++. And that made the migration very easy. But it's also like such a heavy burden on like the way the grammar works. And the language design is so constrained because of C. Like just in this cycle, there was a feature that's broken because of a C feature that we didn't realize was there. And now this interaction is completely messed up. And like essentially, like trying to find syntax for new feature is really hard because it's just we're really constrained in trying to with backwards compatibility. So I wouldn't say I'm loyal to C++. Like I'm a software engineer. I write software, and for the kind of stuff I'm good at C++. So you can use C++ to solve the problems I work on. So I'm happy to use C++ and I have fun doing it. But if there's a different program language that I get to work in, I'd probably have fun with that too, depending on the program language.